clearance and robust suspension systems. There is a critical need for a lightweight, efficient, and reliable electric vehicle to provide sustainable mobility for rural populations. Again, our focus is on the rural populations, facilitating access to markets, healthcare, and education. Now, let me give you a brief about the design rationale. So, what is it? First, we are moving on to the platform choice. We have a three-wheel, low-speed, high-torque utility e-rickshaw, which maximizes payload for minimal cost and leverages existing high-volume micro-mobility supply chains. Then move on to our primary objective. What's the primary objective over here? To deliver a robust, scalable, cost-effective mobility solution optimized for the EVDC 2025 weighted criteria. Okay, so we are moving as per the criteria over here, which was given to us by the EVDC 2025, and by analyzing the criteria, we have designed an e-rickshaw. Now you may ask me, why an e-rickshaw? Why not any other vehicle? The only reason is we are targeting the maximum working class population over here. We know that a lot of people in Northeast, they not majority, but most of the rural population of Northeast, they rely on farming. So instead of like focusing on the population itself, we have a lot of rickshaw workers as well. So why not we inculcate such a technology which is pollution-free and highly optimized for them? So that's why we have designed this particular model. So let me move on to the dimensions. We have length 2.9 meter, breadth, length of the wheelbase, breadth, height. We have the ground clearance of 180 millimeter. We have the curb weight, which will range around 300 to 350 kgs. We have tire width of 18 inch, and we have the. Now let's move on to the platform justification. The e-rickshaw format is an engineering necessity to meet the 15% cost optimization weightage, while enabling investments in terrain, adaptability, energy efficiency, and eco-materials. Okay. So now we move on to the most important part of this particular electric vehicle design, which is the mechanical design for the terrain. 25% weight. So what does this weight signify? This 25% weight is nothing but 25% of the gross weight, which is the curb weight plus external load weight. Designed for gravel, heavy rain, and sustained 30-degree gradability, welded EWS mild steel space frame with an integrated multi-point roll cage, 180 millimeter ground clearance, and cost-effective suspension geometry. Then we have the chassis and the safety cell, welded roll cage integrated into the chassis for occupant and battery protection. Then suspension and clearance, modified mech person's front, semi-trailing arm rear, coil overs, and high-profile tires to reach 180 millimeter clearance. Now we move on to the most important part. Since it's named as an eco-rugged e-rickshaw, like a rickshaw, it's made up of sustainable materials, like basically eco-friendly materials, which focuses on sustainable materials strategy. So what do we use over here? We use bamboo fibers, used for interiors, seat shells, and diffusers, low cost, lightweight, climate positive benefits. And then we have jute hybrid, jute RPP hybrid, the jute plus recycled PP for semi-structural parts plus 44% elastic modulus versus pure PP, cost effective and durable. Again, the significance of 44% elastic modulus over here indicates its durability and strength towards external load and the passenger load as well. Now we move on to the safety and compliance, prioritizing passenger protection. First, let us focus on reinforced roll cage. Rigorous testing ensures robust passenger protection in the event of an overturn or collision. Then we have IP65 waterproof wiring, again very important for electrical systems. All electrical systems are sealed to IP65 standards, guaranteeing operation in Meghalaya's heavy monsoon conditions. Finally, we have fire-safe lithium iron phosphate battery. It utilizes lithium iron phosphate battery chemistry, known for its superior thermal stability and inherent fire safety. Now, I will pass it over to my teammate, Surya Kumar, who will explain you about battery constraint paradox.
So battery constant paradox, we use here a 2.8 kilowatt 48 lithium phosphate battery, which is which force the accelerate and parasitic loss minimalism. That means this battery can give a range around of 40 kilometers in slopes and roads. This battery is suitable for our e-rickshaw because it can provide 40-kilometer range that is very suitable for short trips around the villages in Meghalaya region. And the main aim was of our e-rickshaw was that it is lightweight and strong efficient, and the main thing that it will be affordable for all the peoples. To make most of 2.8 kilowatt battery, we integrated here the lightweight bamboo design. As we know that bamboo is light and strong, which should provide and also it will be available in Meghalaya. So using bamboo in our e-rickshaw, we can also reduce the cost of making the e-rickshaw. So using bamboo is alone, it will not provide the uh, stability that it will come. So we combine it with a small steel frame to make it safe and stable. By doing this, we reduce the overall weight by 25%. So now we will go to the motor efficiency part. So here we use a high torque geared hub motor that is perfect for climbing hills and carrying the passenger. On normal roads, it is written that it can give us a efficiency of 250 watt kilometer, and worst case it draws up to 350 to 400 watt kilometer for validation. And one main thing I want to mention that our e-rickshaw model is using the concept of regenerative braking. It means when a slope will come in the Himalaya area, it will save some energy due to regenerative braking. That will save us to 5 to 8% of energy. Means it will provide extra energy to our battery without expanding the size of our battery. Now I will go to now I will tell you how it is good on slopes. So let me take you to the top versus inclination graph. So here you can see that five degree inclination are equal to these are batteries producing 75.4, and this series goes to 30 degree, then that is 430 point. So our motor and gear ratio are designed in such a way that it can handle up to 25 degrees. The normal rickshaws that can't be able to be at 12 to 15 degrees in the area. So mechanically the vehicle is ready for daily purposes. So let me show how it is connected to the local culture. So as I said that earlier, we are using bamboo from Meghalaya. So and we have added designs inspired by Khasi and Garo tribal operations in the inside printing of rickshaw. So we use shapes and color that feel familiar and traditional to the peoples. This makes the rickshaw not only used but also connected to the identity of the region, so that more people will connect to their culture and use it. So now I will tell you the uses and future plans of this e-rickshaw. As I said that this rickshaw is perfect for short rural roads inside villages, and it is very useful for tourist areas because in Meghalaya, as you know, that the villages are very far and you will not find a charging station, so that it will suitable for the tourist sport purpose. And second thing is expandable cargo version. Our future development includes that we will dedicate a cargo variant to support local agriculture and small business that can carry daily needs for the farmers. And third thing is solar roof upgrade. In upcoming time, we can also explore this integration by installing a lightweight solar panel roof for extended range, and it will reduce the charge dependency on this. So now I will want to that was a rickshaw in Meghalaya region. And so with Meghalaya, we are creating a simple, light and ready electric rickshaw made for the peoples and roads of Meghalaya. Thank you.
Hi, can you hear us? Okay. Can you get to your presentation, please? Yeah. So initially you started the presentation.
Yes.
So there you mentioned a lot about that you are keeping this for rural crop and you are basically trying to address the population, the general population.
Yes.
At what price point are you keeping these vehicles?
So basically, according to the EVPC 2025 specifications, we got the budget to be around 40K, 40,000 rupees.
Is that the selling price?
That's the bill of materials, so to be honest.
That is BOM cost.
Yes.
That comes in your fabrication and manufacturing and the rest of it again. What is the selling price of this?
So we'll be selling this particular for around 1.5 lakhs.
What is the competition?
So I don't know the competition in the market.
Yeah.
So I would say the competition for an eco rickshaw using bamboo as a material will be very less. So basically, we are prioritizing on bamboo, using bamboo for its frames, for its structural stability. So if we compare it with that perspective, then I would say the competition is less. And other than that, then I would say the competition is pretty good. If we only go for the general perspective.
So let me put the question in this when I'm as a lecturer driver going and I'm trying to buy for me whether it is bamboo or it is other material does not matter. So in that case, the competition is not just the ones who are using bamboo, but also the ones in that case. And this is a slow moving rickshaw. So what is the top speed of this?
Speed of the rickshaw. So it's around 50 to 60 kilometers per hour. So according to the EVDC 2025 specific budget, we were limited to 40,000.
And you want to your battery and your and you mentioned your wheel size is 18 inch.
Yeah, that is very important.
18-inch wheel size.
And you're saying 180 is ground clearance.
Yeah,
180 ground clearance and 18 inches wheel.
18-inch wheel size.
So I think tire width is 5 inches. 18 inch, I think it was just a typographical error.
Then what is that 18 inch?
So it's a typographical error.
We have that.
Width. Okay. You know how we classify tires? Do you know that? Let's say for example, do you ride any vehicle, like a two-wheeler or four-wheeler, anything like that?
4 wheels.
A four-wheeler. So in your four-wheeler,
So it's a Maruti Suzuki
800, right? What is the tire size?
So I'm not aware of.
I mean, there will be two heights, no? Either it will be height and width. So what's your height and width?
So
So 18 inches the diameter and 9 inches the width.
Diameter.
Yes, sir.
This circular diameter you're talking.
No, sir, right.
Yeah, let's see.
Yes, sir.
18.
shouldn't be, but actually inner diameter basically is how we classify the tire.
Sir, we are focusing on the big tires because of the material.
18-inch tire goes into a Creta, man.
Maybe 180
Ground
clearance they level.
I drive a Jeep Compass. I have an 18-inch tire. You get the point? How big the tire is?
So 13 or 14 inch का टायर आते हैं.
14 inches.
Actually वो ground clearance ही वो आपका कर रहा है. 180 mm you are saying ground clearance and 18 inches you are saying tire. So how it can be a ground clearance will be less. So उससे ज़्यादा ही होना कोई ground clearance में.
टायर आप बड़ा रखते हैं, ग्राउंड क्लियरेंस भी बड़ा रखते हैं. अगर जो टायर लगाएंगे तो यूनिक नहीं.
Specs are not matching. And okay, now coming to the next slide, can you go to the next slide? I think you talked about the battery and the yeah. No, you had also the motor. Yes. Okay. So, what sort of so you are saying you are using a hot motor, and in a hot motor you are what is the spec of the motor?
1.5 kilowatt.
1.5 kilowatt. 1.5 kilowatt, और आपका बैटरी you had was 48 volt 68
And
uh,
60 and 68. But 2.8 kilowatt hour. Yeah, 2.8 kilowatt hour.
correct. The 2.8 kilowatt.
Anyway,
I think it might be little underpowered.
uh, uh, it might not be underpowered, but it is for very small distance. I don't think you might go for a long distance. It's not even 30 kilometers.
That's what they are
But-
claiming 40 kilometers.
Yeah, you are claiming 40 kilometers, but with this power you might not go between more than 15 kilometers.
So for 40 kilometers.
And you are, when you will ride in a hilly areas, it might go below.
So that's why we are using the magnetic resistance.
Lighting material is something different, but motor itself, if it is running without any load, now it will not go for that much. 40 kilometers will not go. And on the other side, you didn't specify which motor you are using. And one more thing, what is this efficiency? This is not efficiency, this is something else, I think.
Normal सा question है पहले how many three-wheeler rickshaw you have seen in this region? You are claiming Meghalaya, right? What may be the reason why they are not used? It's not like Evo company is not selling here.
So because they are underpowered. That's why they are not good. It's the normally it's a that is the batteries. They are only suitable for 20 to 10 degrees slope, but the air slope is more than 25 to 30 degrees. So that they are not targeting the EV company are not targeting it.
Okay, diesel or petrol rickshaw भी available है. That how many you have seen in Snow?
So in Shillong, many are not here, but sir, few I have seen in Lavan.
Only few, you can count right actually. 3-4 लोग ही जो चलाते हैं. क्या रीजन है उसका? आपने बोला कि टेरेन रोड खराब है. Is three-wheeler is suitable for bad road?
Sir, it is not suitable for battery. That
I mean balance इसका ज़्यादा होता है. 4-wheeler का 3-wheeler,
balance को control नहीं करता.
right? Second point आपने बोला कि रेन बहुत होता है. तो fully covered vehicle ज़्यादा सही है या ये three-wheeler जो open है रिक्शा वो ज़्यादा सही है? ये दो मेजर रीजन है यहाँ पे थ्री-व्हीलर रिक्शा नहीं चलने की. पहली बात तो ये कि बैलेंस ठीक नहीं होता है. दूसरा है कि बारिश होती है तो भीग जाता है
Sir,
पैसेंजर.
that's why we have make it for the village purpose only.
विलेज में भी आप गए अभी तक जहाँ आप इस रास्ते से जाते हैं तो व्हाट दे आर यूजिंग? Obviously not e-rickshaw. And the cost that you are saying for 13 or I mean 20 kilometer, like this power will go up to 20 kilometer, not more than that. The cost is also very high for villagers to afford it because उनको second hand auto मिल जाता है 2 लाख, right? And another power is also issued in village. So how you will charge that? So all these solutions.
That's why we are in future we are started to means plan to install the rooftop solar power.
Yes.
Rooftop is not a solution at all. Because if it's a very small rooftop panel, it might not be, you might charge for 12 to 16 hours, even though your battery will not be full. So rooftop is not a solution. You might have to fix some panels extra in your home area, then you will be able to charge. Because in general, the rickshaw, they charge for 5 to 6 hours, and but with a fast charging, and they go for a whole day. And in that case also they have to charge for 3 or 4 times. So you have to see those things. And battery specifications are very low. You might not go for even 20 kilometers. So you have to see many things. And on the basis of what kind of motor you are using, that are also responsible. What kind of converter you are using, because you are telling about an EV, but you are going, I think, for interior mainly in this slide, not for me.
आपने एग्जांपल जो दिया सिलोंग टू सिंचर रोड, ये हमेशा से खराब है, अभी खराब हुआ है. You are targeting rural area and talking about a highway. So that is also budget is approved by the central government that will be built on. You know about it, right?
Yes, sir.
Yeah. So I mean, examples will also be very close to your problem area.
That's enough, I think. And you show the video. वो आप बनाया हो, मुझे लगा आपने बना दिया है परीक्षा. Last day.
आपका बना हुआ है. मुझे भी लगा कि जैसे आपने बना के
चला दिया है. इसीलिए मैं सब पूछने वाला था, मोटर की स्पेसिफिकेशंस क्या है, कौन सी बैटरी वगैरह ये सब.
बट हम सबको लगा कि आपने बना. यार आई फील रियली गुड. No, it's good. Like you have to have some fun.
So for cars, you said that the energy is not in the bridges, so that is also for the all vehicles, like this car or like it.
Integrated नहीं हो रहा है. पर वो
So it is the road for all the vehicles, not only Nexon.
वही तो प्रॉब्लम है. तो होता ना वो वाला जो आपको दिखा नहीं आ रहा है वही.
So you can see like these EV bus, taxi, I mean, sorry, scooter and all, that you can see in slow. But rural area you can see very less. Only these problems we have to sort out these problems together.
Thank you, Abhay, Kunal, and Sumit. Now we move forward to the last offline presentation of the day. Serial number 13, NIT Meghalaya, Bhavishya Audit.
Number 5.
Good afternoon, everyone. I'm Abhishek Paudel, currently pursuing my BTech in second year in computer science engineering. Here, I'm standing in front of you to showcase my project Migra, the eco e-rickshaw for Himalayan terrain. So let's get into this. सर वो अभी लाइक नया टेक्नोलॉजी है इसका नहीं पड़ेगा.
रात में किया है.
हाँ सर, ठीक है सर. So let's start with the problem statement. So why we are facing, have you seen, as sir told, we have not seen any rickshaws and all in Shillong and Meghalaya. So what are the problems? Sir has told two problems already. The inclined slope the fold stability, the rainfall, and low ground clearance, and this. So the elite stars that we saw in the most of the plain region that are not designed to be used in hilly terrains. The frame, the ground clearance, the motor used is something that is to be used in plain region. So and there is no EV. So in this market, which is targeting the rural market, hilly area. So there is a huge market gap, which this project Meghrat will point out. So our solution, Project Maker. So this is like as we have been told by the organizer that we have some criteria like this. Yeah, like this we were given a criteria. So that's why we built. I proposed two designs. One which was feasible for this criteria, and other which was feasible for Meghalaya. So I have two design. So let's go to the. Okay. So the first one is cost cap warrior that has been like designed as per the criteria given by the organizers. And second, premium picker, which is must for this terrain. So let's go. Okay. So these are the designs, and what is the best fit for this design? This motor, like for cost cap, we are using 1200 watt geared BLDC motor. So which will be used like the speed we are compromising the top speed with the torque generated. So with this motor, gear motor, it will be of less speed, but the torque will be maximized. So like you can just incline that. And battery we have used 48 volt lead acid battery for reliability. So because it is a old battery and it is very heavy, and as for the cost factor, I have used this battery to cover up the sum in like 40,000 because it costs around 14 to 16 to 20,000 for this battery, and to like comprise it within 40,000, I have used this battery. And suspension durable leaf spring, and here is same also like leaf spring suspension is very easy to find, and like that's why I use that. And then cost that 40,000 for and target essential rural transport and the premium breaker. This is the one which is suitable for this terrain. So the motor we can use is 1000 to 3000 watt mid drive for power, and battery 60 to 72 volt LFP to extend range, and suspension gas transfer variable comfort and brake hydraulic brake. So this design will target the premium eco-tourist fleets like there is a gap between Maruti Suzuki and EV like that. No? So we are targeting that market. Okay, so this is something the specification same, and for the safety we have used external rollover protection structure, and materials we can use recycled steel plus jute panels, and for waterproofing in the trigger specification we have used IP67 for this Meghalaya rain and all. Okay, so I have just used as let's see how our model looks. Okay, so here also I have used AI. So how it will look? Something like this. Something like this. It's not the proper model, but it will look like this. The 40,000 one. And how it will look when we will write it in Sora. It will look something like this. And then let's go to different one that we can. Sorry. इधर तो इतना सारा है okay, so this is the that one fit which will be fit in here. So how it will look like in simulation. Okay, it will look something like this. all. Yeah. Okay. So how we can get this terrain and all? How we can achieve the thing that is required here in Meghalaya? So high gear ratio, something we use the gear motor. That's why like we can get the high torque. We are compromising torque speed with the torque generated. That's why the high frequency is the engineering we use and optimize weight design. In that battery is very heavy, so we will keep it in the rear end. So that's why the center of gravity will be mass and the traction and stability will be so I'm not a mechanical student, so that's why I'm.
That's not.
Okay, it's fine. And enhanced ground clearance and IP67 waterproofing is there, and LCD grade suspension, light con vehicle water suspension system. Then eco material integration. So we can use jute hemp, natural fibers reinforced polymer for environmental impact. We can use the recycled steel for this frame, so it will be sustainable. And as we know that, like in Meghalaya, there is more like bamboo in areas and things. So we can use as bamboo will decay. So we can use some like resins that don't decay and fuse it with bamboo so to make it fit for this rain and all. So we can use recycled plastics for the interiors also. And as in the premium segment, we can use electric battery, which can be reused if the after 6 or 7 years, if the battery goes down, we can use it in rural areas like in house or something. In schools, we can use then the power like a generator and all. We can use that and reuse seating. Like we can make the seat from reuse forms and all. And okay, as per the criteria we have provided, so we have used eco materials, energy efficiency, cost optimization, safety, like roads and all, and aesthetics also is there, like Hasi, bamboo and all. So how can we position this cost cap barrier and premium factor in the market? A design which cannot be implemented in the market is useless. So how this design will work? So this will, as the cost cap barrier will have a low cost, it can replace the traditional cycle rickshaws and low-end rickshaws, which are not here but in some reasons. And in Sora also, this is a plateau. So we can use this also here. Okay, then premium taker. This will be fit for between the high-end EV and e-rickshaw. So it will be between that. So the e-rickshaws can increase the budget and buy this. Okay. So conclusion. So project maker delivers a comprehensive solution for sustainable and robust electric mobility in challenging terrain. So we can with the help of project maker we can have a terrain ready dual design approach. We can, as I said earlier, eco materials that we can use bamboo and all, and local feasibility. Those all the parts that I have mentioned are like fit for the Indian market and are being used by the top Indian giants like Mahindra and all. They have used and deployment ready. So let's. I have just built a simple Python simulation for this ECU, how it will, how the sensors and all will work. So let's see. Okay, so this is the something visualization of that. So we have forward gear, neutral gear, and reserve gear. So when you give the throttle, let's see, and first we'll check the gear, then we'll give the throttle. Then we have battery percentage and motor torque, how much is generated, current drawn from the battery, speed, and incline degree. We can also increase the degree from here, like inclination. So if we incline more and the throttle is less, we'll have a warning signal. And when we will increase the floater, it will not fine.
The simulated parent incline, as it goes higher, why is the speed going higher at the same throttle?
Okay. So, yes, sir.
Now your speed is 34 kilometers per hour, right?
Yeah.
You increase your incline.
So this is the simple simulation of ECU, and
Your throttle is 10%.
yeah,
I cannot see that. The throttle is 10.
10%. Yes.
Can you increase your throttle? Make it to 40. Somewhere like half. Increase your incline. As your inclination is increasing, your speed is increasing.
So I think it is because speed is constant and the total
Throttle is not.
throttle is constant and increase. That's why.
क्या होगा?
स्पीड कम होना चाहिए ना
ये घटेगा ना?
Like sir, this is a super simulation. तो थोड़ा
सिंपल माने गलत हो जाएगा क्या?
तो एज केस मिस हो गया थोड़ा.
और इंक्रीमेशन कहाँ तक दे रहे हो?
So वो 30 degree that we were provided in that. सर इस ऐसा है कि स्पेसिफिकेशन हमें प्रोवाइड हुआ था तो उसने थोड़ा इधर उधर ये
Simple comparison, previous one they have presented now, so 30 degree, 35 degree, something torque something 350. आपका torque आ रहा है 30 के आसपास. बहुत कम है. हाँ, 30 पे करो.
And short भी नहीं बढ़ रहा है थोड़ा. Short उतना नहीं बढ़ गया.
Effort is good,
Yes.
but a little bit more refinement.
Yes. So this one I made like a simple simulation.
Second year ना?
Yes, second year.
More time.
But yes, one thing you should keep in mind, you should not use lead as a battery when you are designing EVs. You should not use you should not use a lead acid battery when you are going for EV because weight is the main constraint. You are saying this, it is heavy, you should not use. Go for LPF, which is you are using for another tracker. That is fine.
So वो cost 40,000.
No, though it is, but if you are putting the weight, that will not go that much different distance you are defining for. Okay, otherwise it will study exam में नहीं बन पाएगा.
वो इसलिए हम लोगों को कोई like specification कोई से दिया था ना तो हम
40 में बना के चलाना भी तो है, खाली रखना तो नहीं है.
Thank you. Thank you. Thank you, sir. Thank you so much.
Thank you.
Thank you, Mr. Now, last but not the least, we move forward to the final presentation of the day by Sakshi Sinha from West Pilani, serial number 6. Now we call upon Sakshi Sinha from BITS Pilani, serial number 6.
Hello,
Yes, you're audible.
I'm audible.
Yes.
Good afternoon, respected jury member. I am Sakshi Sinha from the BITS Pilani. Let me start with one simple truth that the people of the Bengali are paying that the price of the mobility that was never built from them. Steep the slopes, mud, tracks, the broken rural paths, and the conventional vehicles keep the brake or simply at the give up. So I can ask myself, and I can ask for yourself also, what if there was a vehicle designed for the area and not for adapt to it? This is a question lead to the in or the electric fuel vehicle that I can build for the Meghalaya region. This is a EV vehicle that provide people the reason from Meghalaya.
Sakshi.
The Meghalaya is the one of the reason which is highly
Sakshi,
grateful. Hello.
your slides are not changing.
Oh my God. Yes, yes, sir. Yeah, yeah. The the problem and the solution that I can see, the challenge, the result is the high fuel and maintaining the cost for the global community. Our solution is the compact four-wheel electric motor. It is the purpose built with a high electric multi-driven and continuous operation and it hold the sustainable efficiency with taking the efficiency and capture the energy and the hill hall sustainable development. This is a bamboo fiber panel that made from the recycled steel for the safety vehicle includes the steel body and this belong to the reason the tribal people from the Khasi and Janta people from the Bengali and this will be helpful for the targeting the people from it is the smart design and it also provides the farmer and micro factory approach and it also helps the bulk from the local assemble and the job creation also. As an entrepreneur, as a management student, I think as an entrepreneur, I think it helps us to give opportunity to local partners and local community or from the Meghalayas, they can approach for this creation also. And the final, this feeling hall, electric hall is more than just a concept. It is the run efficiency culture that align with the future of the sustainability and the mobility of the Meghalaya. Thank you very much. I'm open for the question.
You actually asked us to present your presentation from here.
So that's
We were actually requested for us to present it, present your presentation.
Yes, sir.
Hello.
Hello. Yes, sir. Yes, sir.
Like we are presenting for your side, kindly you can say that when we change, when we take the class as accordingly.
Sir, I completed my whole thing.
Okay, so can you give a brief about the design, which would that design is like for you? Just give us a brief of that.
Okay, sir. The design of the tip is I use a in this slide what I made for this model. I use a eco materials this eco materials are highly sustainable like bamboos and hello.
Is there any design specifics that you want to share?
Yes, sir. This one. My slide.
Okay,
This is my model design.
this is your model design.
Yes, sir.
Anything specific to the battery capacity, the tonnage of the vehicle? How are you achieving two?
Change you want.
Sir, it can help the people for the
How are you?
hello.
Is there a slide where you have the vehicle specifications mentioned, like the battery capacity, the type of the battery, the type of the motor? Okay. So it's a 30, 45 kilowatt.
Like this the battery controller. Like sir, totally
And you have a 6 kilowatt hour battery.
yes, sir.
30 to 45 kilowatts.
Means how long will the vehicle run for?
Hi, Sakshi.
Actually, I just don't know about the pattern how to draw. Basically, I draw the rough speed diagram and then I need to
So you use ChatGPT for making your presentation or something.
sir,
Then how you can
diagram,
then how you can run a 30 to 45 kilowatt motor with 6 kilowatt hour battery? Are you a electrical engineer or some computer science?
No, sir. I taken a research about this project also. Like I taken what are the basic reasons, what are the problem the hilly area people Meghalaya people facing.
Okay.
Do you have an engineering background?
No, I am from management background. That's why I draw this picture only light and deeper help for the chatting for drawing the pictures also. Actually,
So you have any person who is related to technical background who can answer such questions, or you are alone right now?
So I just aiming as being a future entrepreneur. I just want to participate in like invest in this type of project.
Okay. We can see. I mean, this is a nice effort, but you have to do some research also in technical areas, then you might be able to do much better. I think so.
Yeah, and also another thing is that you definitely, when you are handling this kind of technical concepts, you would require somebody who is technically apt to actually help you out with these specifications and everything. Like these kind of rudimentary design issues that you are.
Pardon. So this also gives a, benefit like a local community. By opening this type of vessel, we provide a petrol engines. Local community get benefited. Like
But first of all, one minute, please, please listen to us. Please listen to us. But to have that business, you first need to have a product. To build a product of this technical complexity, what we are saying is that you should look into someone or you should work with someone who has the technical understanding and knowledge of this. Make sense? Thank you.
Oh, yes, ma'am. Thank you, sir.
Thank you, Sachin. That's all from our side.
Thank you, sir.
Now we call upon Mr. R.S. Raman, General Secretary to Science and Technology, to give the summary of the event.
Good afternoon, everybody. With this, we come to the close of our Mega Drive EV Challenge 2025. A huge round of applause to everyone who has been here and activated. Across India who have shown their interest to take part in this competition, out of which today we had approximately 15 teams who had presented online. And with this, now we leave it to the discretion of judges. Your scores are being tabulated and being declared shortly. Finally, I want to thank the Entrepreneurship Cell, the Team Cognitia, Institutional Innovation Council, and the Student Activity Center, who has been a constant support throughout these events which have been lined up in the past 3 days. They have worked really hard, guys, and we really appreciate it. And with this, we come to the close of the competition. And all the best to all the teams. May the best team. Thank you.
वीडियो के लिए नहीं तुरंत कल करो
सर दोनों पेजेस पे करने Top 5 super.
Good afternoon, everyone. Now we are ready with the recommendation of our judges, Dr. Pallamachi and
Nikhilesh.
please, Nikhilesh. And our judges from the morning itself gone through all the presentation in detail and has keen interest while you guys are presenting your ideas. So it was a lot of learning from you guys, and finally the result for this competition are with me. So I am going to announce the team names now. So judges has recommended top 5 teams out of the teams which is presented. So fifth position goes to NITM serial number 11 Abhay Mishra and team. Fourth position goes to TAPI serial number 4 Chinmay Khare and team. Third position goes to team from Thapar serial number 13 Aditi Khanna. The runner-up of this competition is NITM serial number 13 Bhavashya. And finally, the winner of this event is NITM serial number 10 Ujjwal Jhajaria and team. I congratulate all 5 teams, those who have secured their position in this event, and special congratulations to winner and runner-up for showing the remarkable work and design thinking for this event. Thank you all. ये document it is complete. So, one first page. Second. ओके, अगली बार से थोड़ा सा बड़ा बनाना है. That's good. Like in second year, you have shown some interest. We'll give you next event. Very good.
With this, we conclude today's event. Thank you everyone for joining us.
बना दिया इसमें